integers, nums, and an integer target return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. And you can return the answer in any order for the indices. So here, if I look at the given examples in LeetCode, you see the numbers assigned to 2, 7, 11, and 15. So this input is sorted, and the target is 9. So if we just solve the problem manually, we see that if we add 2 plus 7, that's 9. So the indices are returned. So let's look at the second example. So here we see nums is equal to 3, 2, and 4. So this is an unsorted list. The target is 6. So when we look through, if we compare 3 and 2, that's 5. So that is not equal to the target. And if we compare 2 plus 4, that's 6. So here we see the indices of 1 and 2 are returned. So here in the third example, we see an array with the same values, 3 and 3. So when we add those together, that equals to the target, and that returns the output of 0 and 1. So here we see when it says you may not use the same element twice, that's referring to the indices and not the actual value of the element. So the brute force solution would be a nested array where you compare every single value to each other, also ensuring that you're not comparing the same value at the same indice. Now the time complexity of that will be big O of n squared, and the space complexity will be big O of 1. Another way to improve the time complexity for that is to utilize a data structure such as a map. And the reason why we want to use a map is because we need to keep track of the value of the element, and we also need track of the index where it's stored at, its original place in the input array. And so essentially the solution to the problem would require that you instantiate a map, you iterate through the values of the nums array, you calculate the difference of the target minus the current element and find out what the difference is, and then you check the hash map to see if it is found. And if it is found, then you simply return the indices. So the time complexity of that is big O of n. It's linear because we're simply doing a linear search. And the space complexity is big O of n because we are creating that hash map where we are storing values in that data structure. So implement that, we can say const map equal to new map, and we're using TypeScript, so I'll specify the data types. So the key is a number and the value is a number. So now what we want to do is we can instantiate let indices. So this will be the value that we are returning. And then we want to iterate through the nums. Now when we iterate through, we also want to keep track of the index. So we can do that with nums and just the built-in for each method. So we will use the number, which is the element. And with the second parameter, we would use the index of where it is in the array. So we pass our arrow function. And so first what we want to do is calculate the difference. So we'll say const difference equal to target minus num. And now we want to check, is that value found in the hash map? So we can check if map.has diff. So if it is found, then we can simply specify it. So it doesn't matter what order the indices are, so I can just say index and then map.get diff. But otherwise, map.set the number and then map it to where it's found, its index. And then just return the indices. So here if I run it, it successfully passes all the tests.